Good afternoon, everyone. Thanks for attending. You're very welcome to our workshop today, titled Pathways to Energy Efficient Manufacturing. So this obviously is a virtually hosted workshop as part of Sustainable Places. It's unfortunate that we couldn't be together because I think there's great potential for collaboration across all the FOF9 projects, but hopefully we can do this in the future. So my name is Alan McGibney and I moderate today's session with the help of our speakers, panelist team, and of course you, the audience. We're hoping for an informative and interesting and somewhat interactive workshop if we can. So given your interest in today's workshop, I'm sure many of you are aware that energy efficiency remains one of the most effective short to medium term targets to reduce industry carbon footprint, and that this needs to be considered at all stages of the manufacturing process. So from the perspective of the projects that are represented here today, we strongly believe that Industry 4.0 and the digitalisation of the manufacturing processes offers significant opportunities for energy savings. So we can achieve this through the optimization or replacement of technologies, the application of new software tools for energy efficient management, and the adaptation of existing business processes. So as such, we'll explore this beyond the individual projects and try to take a holistic view on defining appropriate pathways for energy efficient manufacturing. So I'd just like to take this opportunity to thank all the project coordinators for their commitment and openness in supporting and making this session free of charge. So we couldn't facilitate this workshop in person this year, but we hope that this first joint workshop with the FOF9 projects will be a catalyst for further interaction and a collaboration across all of these individual projects represented here today. As I mentioned, we don't have open dialogue due to bandwidth restrictions on the tools that we're using, but we have a number of mechanisms to leverage to facilitate the engagement. So your input is critical for the success of the workshop, and we'll use the tools such as the session chat and the Q&A to spark any conversation around topics discussed, and we'll use the online Miro whiteboarding tool to solicit and collate and pull together the different inputs from everybody. So the link for the Miro is in the chat, and with that I thank you again for participating and being part of the session, and I'll hand over to Susan maybe to introduce the structure and the expectations for today's session, and I hope that you all enjoy the workshop.
Thanks, Alan. I'm just going to share my screen, everyone, if you just bear with me. So as Alan mentioned, we're going to use the Miro tool here today, and I'm just giving you a sneak preview of the tool, and we'll give you some further instructions on how we propose to use the tool as part of today's workshop. So first of all, to reiterate what Alan already said, we're delighted that you could join us here today, and thank you very much for participating in this workshop entitled Pathways to Energy Efficient Manufacturing. So my own name is Susan Ray, and together with Alan, we coordinate the DENiM project. So DENiM is one of 4 projects that were funded under the Horizon 2020 Energy Efficient Manufacturing Systems Management, and this was funded under the Innovation Action Programme. So together with DENiM, we have ECOFACT, E2 Commission and ENERMAN, and today as part of this joint workshop, we're going to hear from DENiM, ECOFACT and E2 Commission, and we'll follow up with the ENERMAN project offline. So the specific challenge to be addressed by this topic, and hence these projects, is to improve industrial energy efficiency through the holistic integration of energy data into production management systems in order to provide significant energy savings. So that's what we're going to talk about today, and talk about how these projects are addressing that challenge. So today is our first joint workshop that brings together DENiM, E2 Commission and ECOFACT. And our objective is to explore the synergies and opportunities for collaboration across these projects. And our hope is that we can develop a common pathway towards energy efficient manufacturing. So as part of today's event, we're going to begin with an introduction to each of the projects. We'll then identify their synergies, and out of that we'll begin the process of understanding industry readiness with respect to sustainable manufacturing and creating an initial common pathway towards energy efficient manufacturing. So today's agenda is here in front of us. The first session really is an information briefing session on the projects themselves, and that will be followed by a number of interactive sessions where we'll explore the concept of pathway setting and how we can use this concept within DENiM, E2Commission and ECOFACT to develop a common pathway towards energy efficient manufacturing. So as part of today's workshop, we would like you to be open in sharing your opinion and feedback. And because you've joined the session, we're assuming you're interested in this topic. So we'd be delighted to get your perspective, and this will broaden the perspective of the individual projects here today. We'll use the chat and Q&A functions along with the Miro tool itself to capture our discussions as we move through the day itself. So we're going to begin with an introduction to DENiM, followed by ECOFACT and E2Commission, and after that then we can take some questions, so please use the Q&A function. So before we start, as I said, we'll give you a quick introduction to the Miro tool. So Alan is going to take us quickly through this just so you can familiarise yourself with the tool and how to use it and how to participate in the active sessions. So once more, I'd like to thank you for joining this workshop, and we're delighted to have you present and indeed to share our perspective on energy efficient manufacturing. Thank you very much. So Alan, I can hand back to you.
Perfect, thanks Susan. Yeah, so depending on how familiar you are with the Miro tool, there's just a quick exercise really to kind of allow you to maybe introduce yourself and get familiar with the different tools. So on the side here, you can see a list of frames which goes through the different steps basically of what's being presented today, and you can bring that tool up using this toolbox down at the bottom, and you can see here frames. So when you click on frames, it brings up the different slides basically that have been presented. And on the left side here, I suppose the most important thing is this sticky note or this post-it, which allows you then to drag information onto the Miro board, which is like a big whiteboard, an online whiteboard, and allow us then to basically collate and collect information. You can use the hand tool to select to move and to zoom, and there's a few instructions there on how to do that in the platform that you're using. So as we begin the session, the projects, what you can do if you're part of the DENiM project, you're aware of it, so you can use that time to maybe add a few sticky notes to the Miro board while you're listening in the background, and give it a little insight maybe of your area of expertise, so for us to capture the different domains people are from. And then there's a kind of a guiding question which basically asks, what's your opinion on the key drivers and barriers for energy efficient manufacturing systems? So as an example here, you can either select a post-it from the side, double click on it and type in, so academia for example, or IoT or edge computing, or if you want to put your organization, you're free to do so, whatever you like. Or you can use the sticky note tool here and just post your sticky note and type away. So you can use that as a starting point to get used to the Miro tool as the presentations are ongoing, and then we will progress to the other parts of the workshop following those presentations. Okay, if there's any questions about that or challenges with using the Miro tool, then you can pop it into the chat as well, and we'll try to address them as we go along. Okay, so with that, I think I'll start the presentations just to get going. I mean, we have a 3-hour slot, but we'll see how it goes, and it may not take that full 3 hours because I understand it's late in the evening for some people. So we'll just get started here. I might just share my camera as well, just to be. See. Okay, so first project, DENiM. Just maybe a little bit more about myself. So I'm Alan McGibney, and I'm from the Munster Technological University, which is based in Cork in the south of Ireland. I've been working in European projects for quite a number of years now, and involved in energy efficient projects, energy efficient buildings, automation, and anything really related to ICT and its application to energy efficiency. More recently, we've been quite active in smart manufacturing and energy efficiency applied in the manufacturing domain. Seemed like a logical step in our kind of strategic view. And I'm part of the collaboration team with Susan and a couple of others at NTU for DENiM, the coordination team for DENiM. So DENiM stands for Digital Intelligence for Collaborative Energy Management in Manufacturing, and the project began on the 1st of November 2020, so we're almost 12 months in. I guess it's been quite a challenging year, like for all of the projects in terms of COVID and getting access to face-to-face meetings and on-site, etc. But we've achieved a lot in that 12 months, and throughout this presentation, I'll give you kind of an overview of the project ambition and goals, and also what we've achieved in that time. So we're all aware of the positioning and the need for the industrial sector to address energy efficiency and to become more sustainable. So with the escalating production and increasing production, there's also a need to kind of make this more efficient and more sustainable, particularly those in the energy intensive industry sectors. But there's a number of challenges around that and managing energy efficiency. And these are a few highlight that what DENiM are looking to address. One of the key issues, I suppose, is getting access to the different data sets. Once you have the data, then you're better positioned to make better decisions. But they're typically kept in silos, and it's about getting access to that information and unlocking the potential for energy savings. Energy efficiency is often viewed independent of the production process, and there mightn't even be specific roles to manage energy efficiency in different sectors depending on the scale and size of the industry itself. I suppose it's quite challenging, and there's a lot of manual analysis done on data and kind of estimating where energy is used and identifying the flows. So this needs to be automated to some extent. And we need to integrate a more continuous planning and decision making supported by sustainability metrics and energy efficiency targets. There's limited interaction with the grid at the moment in practice. There's a few pilot cases and case studies done, but it's not really widespread. So this needs to be enhanced further. And one of the key aspects is there's a gap between the skills for managing energy, IT infrastructure, and data, and the process as well. So digital skills gap needs to be addressed as well. So from a DENiM perspective, we aim to address these challenges on the premise of 3 key strategies. So firstly, we feel that systems need to collaborate, and that's across technologies, industries, and responsibilities or business functions to allow us to uncover energy flows and then unlock efficiencies. Secondly, we feel continuous performance auditing is essential to ensure precise predictions and efficient energy target management. And finally, manufacturing systems have to evolve and adapt to changing operating conditions, requirements, and system configurations in order for us to support and promote sustainability. So to address these 3 strategies, DENiM is looking to develop a digital intelligence platform. So what that means for us is essentially we're going to create a suite of enabling tools and advanced digital services that can be then used to optimize existing workflows and product manufacturing. And that's driven by energy efficiency targets and sustainability goals. So there's a number of different tools, and I'll go into a little bit of detail of each as I go through the presentation. But ultimately, we're bringing it together into a single digital intelligence platform for the manufacturing industry. So we're grouping them then under what we term innovation pillars. So there's 4 interconnected innovation pillars that really encapsulate the objectives of DENiM. And these are creating enabling technologies, developing digital services, workforce development, and then promoting best practices in business practice, right? So to start with, from enabling technologies perspective, we're probably all aware that in the industrial domain, advances in ICT technologies such as IoT, cloud computing, big data, digital twin, and AI, all under the guise of Industry 4.0, is providing significant opportunities for manufacturers to get access to, I suppose, unprecedented amount of data from physical machines, the shop floor, and the surrounding environment. So all of this lays the foundation for the creation of a digital ecosystem. And DENiM aims to leverage this digital ecosystem. So we're using if we start at the kind of shop floor level, we want to create this intelligent edge. So DENiM is leveraging technology provided by our SME partner, Bulgaria, to support interoperability and integration at the edge. So this then should enable extensibility, make it easy and fast to set up, and a particular emphasis on integration of legacy equipment. So the convergence of operating technology in IT security and IT roles, if you like, is kind of the convergence kind of becoming a little bit more blurry. The overlap between them is coming a little bit more blurry, and security is a real concern in this case. So DENiM will address these via 3 components of the platform. The first one being identity management, access control, and authentication. So we need to make sure that all devices, machines, data sources, endpoints within the systems are identifiable, and access control is managed to mitigate against risk of rogue or untrusted devices connecting to the network and potentially taking control over any systems or machines. From a communications perspective, you need to encrypt everything between the devices to ensure privacy of the data being transmitted. And ultimately, if the data is not good, we can't use it effectively. So we need to ensure the integrity of the data that's being generated from the different systems, physical systems. So the availability of the data is more efficient for business, but the value of it is limited unless we use these new digital records to motivate new methods for its use. So it's not about simply mimicking old processes in a digital form. It's about creating new innovation through the use of this data. So this is not without its challenges. Organizing and sifting through vast amounts of data now available is to generate kind of meaningful information is very complex. And this is where data-driven software maybe comes to the fore a little bit. So DENiM will create a core data management framework, and this supports the creation of what we refer to as the cognitive loop. So that's the ability to first sense using, as I mentioned before, the intelligent edge to extract data from the physical world. And then we can use data processing and machine learning to autonomously learn patterns and identify trends which are linked to the performance of different entities or assets in a production system. So this can be equipment components or to the whole facility. Then these allow us to create models that can be used to proactively act to ensure we're operating in a way that meets our needs, and finally provide stakeholders with the relevant insights needed to operate the system and respond effectively to change. So within DENiM, our partner EDNR is leading development of our data architecture, and it's based on the Lambda architecture principles. So this is about balancing latency, throughput, and fault tolerance. And this is combining both batch processing and simultaneously using real-time stream processing to provide views of real-time data. So the architecture is built using open source technologies, and the idea is to support ease of integration with existing business processes and leveraging a microservice-based approach to support deployment of modeling, simulation, and machine learning services, and support ultimately the creation and deployment of digital twins in this virtual domain. So one of the key aspects of this data platform, and I guess it'll be common across all of the projects, is that we need this kind of common data model, right? We need to be able to share the information in a common way. So within the project, we leverage a semantic model, and this should support the sharing of energy performance data and platform-related data integration. So we're looking initially at the ETSI Smart Applications Reference Ontology, or SARF. So we're exploring that as the option for this, and other standards such as Asset Administration Shell, etc. But also the extensions of SARF for energy and SARF for industry and manufacturing are components as part of that. So once we have access to the data, the next step is to convert it into what I mentioned already, the valuable insights for an organization. And this is the role of the digital services. So this innovation pillar around digital services. So manufacturing requires energy. Okay, we know that. We can't simply shut everything down. So for DENiM, the digital services have a common goal. It's to allow an organization to be more productive with every energy unit, every unit of energy that they need to use. Okay, so where do we start with that? Firstly, we need to understand how the systems are performing, identifying these energy flows. To achieve this, DENiM is utilizing digital twin. So there's many different facets of digital twin, and it's not always straightforward, or hasn't really been demonstrated successfully implementing full digital twin in complex industrial settings. So DENiM will consider energy-centric digital twins from the perspective of, firstly, creating a digital model, which represents the physical object or process. So this can be typically built in an offline representation. We take this a step further then to create digital shadow, where you have the physical object integrated with the data coming from smart components and sensors, and we gather that real-time status and the working conditions of these assets or processes. And then towards digital twin of a process or a system, which ultimately gets richer every second of operational data that's generated from the physical world it represents. So for DENiM, we aim to use and develop these digital twins to uncover energy saving opportunities. And this will provide us with that kind of what if analysis capability within the virtual domain. So there's some technical considerations to achieve this, such as reducing the complexity of the models, the scalability, interoperability, and information synchronization. So DENiM is looking to develop strategies and the toolkit to support the uptake and rollout of digital twins, as well as their reuse across different sectors and systems. So additional digital services include lifecycle assessment and lifecycle cost analysis. So these are long-established techniques, and they've been used previously to support monitoring energy-related flows and data, but they need to be enhanced further with kind of near real-time intelligent data and management of the production systems. So DENiM will provide this decision support tool to promote more environmentally sustainable processes through real-time calculation of their sustainability performance. The online LCCA tool for the cost assessment will help practitioners kind of find the most appropriate options from an economic and cost point of view, because cost savings is quite an important aspect. And these savings can be achieved either through the reduction of energy consumption, the process efficiency itself, or even decreasing the amount of failures, waste, and falls that might be happening in the process. Utilizing the digital twins for energy modeling and the LCA and the LCCA, DENiM can provide or encapsulate this into a decision support system. And this allows then the user to integrate energy and sustainability into their decision-making processes and existing business functions, right? So this constitutes 5 interconnected tools covering different aspects from planning, operational, and control. So in terms of planning, for example, DENiM will develop a sustainable production planning tool that's coupled with the LC and the LCCA analysis approach, and it'll allow for reconfiguration and optimization of process parameters, and supported with the objective to minimize cost and environmental impact, right? So this will then be supplemented through the definition of economic, environmental, and energy performance, key performance indicators, so KPIs, supporting the creation of sustainability-related labels. So this will allow then for a quick and easy metric to support decision makers and potentially product customers. So we can assess then the energy efficiency as a result. When we look from an operational perspective, underperforming assets and I suppose auxiliary services and equipment can provide significant negative impact on energy efficiency. So through the foundational approach of DENiM data platform, we're able to provide additional support to asset management. So this can be condition-based monitoring, it can be predictive maintenance, or even the use of just low-level fault detection systems that helps us minimize waste, machine failure, and avoid unplanned stoppages in production. Taking it another step further then, in line with the view of industry becoming active participants in the energy transition, it's critical, I suppose, that we're able to allow manufacturing systems maximize the energy generation sources, as well as integration with the grid. So as such, DENiM will develop novel approaches that minimize emissions and costs through energy prediction, simulation, and optimization-based framework. And that focuses on advanced energy systems, including energy supply chains, energy planning, and scheduling. So we leverage statistical and machine learning models based on the data that we're able to collect for predicting the performance of renewable energy sources, the demand, the evolution of the market, and the behavior of the electrical grid itself. So all of this will be combined with a model predictive control to adapt processes in order to maximize the use of renewables in the production system. So we have all this data, we have all this information, and we've even converted it now using the digital services into usable insights. So it's imperative for us then that we provide, I suppose, a single shared knowledge source that improves collaboration and communication across workflows. So the foundational approach to this is creating flexible data dashboards, and this can be used then to present KPIs in an easy to consume manner depending on the context of use, so you can very quickly understand what's happening. The other level, or the other extreme, is the use of advanced technologies such as augmented reality or virtual reality. And we've certainly seen a kind of a growing interest and desire for this technology through our pilot partners, but other manufacturing industries as well within the different domains. And I suppose the technology really provides many opportunities such as rich data visualization and interaction, but it also allows for hands-free operation in certain areas, training, assisted workflows. So what we'll do is we look at the value of these technologies within DENiM in the context of energy efficiency. So as you might have seen, DENiM is built on the principle of digital technologies, okay? And we hope that this will bring added value. And to make this a reality, we have to ensure two things. We need to firstly make sure that the organization is in a position to maximize the potential of these advanced tools and services. So that's that technological analysis. So are they ready to take it? And if they are, what if they're not ready, how do they get there? And the second thing is, are the workforce firstly open, and are they willing to embrace these technologies in their everyday lives? And do they have the skills necessary to make that transition? So to this end, DENiM will kind of incorporate this human skills and technological analysis to incorporate an approach that will ultimately lead to a roadmap, or as we're trying to achieve today, maybe a pathway for digitization, skills and training. And if we're to create and promote best practices, we have to be aware and we have to be cognizant of current and future standards. And this covers aspects such as energy data management, manufacturing systems, energy auditing, certification and policy that all influence energy efficiency. So we're working closely with different national bodies, National Standard Authority of Ireland in our case, for example, and EU standard bodies, so we can proactively contribute to these standards and ultimately kind of implement these standards in a way that the industry can embrace them further. As well as standards, there are obviously legal and ethical considerations, and DENiM will provide a framework that ensures any consideration, particularly revolving around data protection, since the solution is very data driven. So we're developing this kind of data protection framework that is followed throughout the development and the application of the proposed solution. So as we develop this solution, we make sure we're adhering to these requirements. And when we deploy it, obviously we ensure that we cover any ethical or legal requirements that are needed at the different national sites and the industrial partner sites as well. So as I mentioned, the consortium is made up of strong partnership across 18 partners, covering academia, bringing novel solutions around energy efficiency, data management, IoT, digital twin, etc., and technology partners, because it's an innovation action. Obviously, we want to achieve a higher TRL level, so we don't start from scratch, and we have some existing technologies that we're building on, so we have a good foundation. Ultimately, it's really important for us then to show the value of the DENiM approach in real world conditions. So as such, we have four complex pilot sites covered, and these look at different industry sectors to evaluate and validate the added value DENiM can bring to an organization. And also, these pilots then allow us to create a kind of a community of practice across these different sectors and the EU and these diverse industry players, if you like, with a view to sharing lessons learned and approaches. So this should strengthen and allow the EU to demonstrate leadership in energy efficiency and sustainability in the manufacturing domains. So the four pilots are diverse in nature and digital maturity, I suppose, would be the term. So each company brings with it very different challenges and opportunities to showcase DENiM. And just a little bit of detail on each of them. So in the Irish pilot, the pre-case, it's about focusing on sustainable production planning and ultimately maximizing the use of renewable energy. So it was established as manufacturing facility in Cork in 1997, and it creates or manufactures orthopedic knees and hips, so these medical devices. And through the use of the DENiM solution, we look to increase the level of digitization along the poly value stream and ensure that there's visibility on the energy performance and energy usage, and also the reduction of scrap and waste. Another big part of this is fault detection diagnosis linked to the auxiliary services that supports the production line. So these can be AHUs or chillers, and these are significant energy users in that context. And lastly, as I mentioned, was maximizing the use of renewable energy, which is wind generation at the site during the production process. Our second pilot is a combination of CDNOR and CI Galfer. So this is based in Spain, and they're focused on energy efficient steel making and forging process management. So there's quite a number of complex steps and energy intensive steps along both of these sections, the steel making and the forging. And the idea really is to develop both energy and process models to support the optimization of operational parameters towards making these individual sub-processes more efficient, and ultimately as well to use this kind of real-time data and real-time information to enhance their existing life cycle cost assessment, life cycle analysis with online data. So our third pilot is in Gorenje in Slovenia, and the focus is around developing digital twins of the machining processes for production planning. Ultimately, there's a lot of activities and sub-processes across machine assembly and tryout, and they develop tools for the appliance manufacturing and the automotive industry. And what we want to achieve is more visibility, I suppose, on the energy and resources used, so more accuracy in that sense. The powering down of machines or milling machines that aren't being used at the time, so obviously involving better planning, overall energy consumption reduction, and basically better job planning, and through decision support, reduce overall electrical energy use, have a reduction of life cycle cost by combining all these actions. And there is a focus on improving the digital skills of the company personnel as well, moving towards more digital supported approach rather than relying solely on their know-how and their knowledge and expertise over time. And the final pilot, pilot 4, which is probably one of our most challenging one, is on edge intelligence for continuous energy optimization of industrial machines. So this is in Italy. So MET is an SME, and that supplies critical components for format change and semi-finished products, so plastics and screws, flanges and brushes, etc. So they're quite kind of reactive to different orders, etc. And each component is manufactured for 2 or 3 machining steps and assembled then as well within the plant. So this is very challenging from the perspective it's really starting at a kind of a lower maturity level. So there's little to no visibility on energy consumption. There's no monitoring at process level, and there's no LCA or LCCA view on the products and processes. So with DENiM, we want to acquire that visibility on energy related elements that can influence production cost, and allows them then as well to kind of quote better for and more accurately for the orders that they get for the different products. We want to introduce energy optimization and optimize different variables and choice for optimal production setup and scheduling. And through other partners and the cluster partners at this site as well, develop a smart energy app for the CNC machines that allows then kind of that continuous monitoring and deployment of after-sales service and monitoring. We want to obviously increase the monitoring of environmental impact of the products that are manufactured there, and provide capabilities to visualize the asset energy use in real time and integrate digital twin to predict the performance of those. So as I said, we're almost a year into the project now. It was quite challenging, but we've achieved a lot, and these are a couple of those key achievements, I suppose, among others that we have done in the last 12 months. I mean, we started off the project with a real good, strong engagement with our pilot partners and external advisors on the kind of needs and requirements of industry. And this allows us then to kind of understand, okay, what do we need to target? What are the KPIs from an environmental, economic and social assessment perspective? What's the reference architecture to provide this digital intelligence or this DENiM core platform? how do we develop this common model? And we did analysis of the different semantic models that can be used and selected the approach for DENiM. We did an analysis of the skills assessment and the kind of digital maturity methodology. So we defined that methodology, how we're going to assess that, and we developed a number of archetypes to map skills required that can align in with training that can be offered at different pilot sites. We've done quite an extensive baseline audit at each of the pilot sites, and this is kind of ongoing with the complexities of being not on site, but we have a good understanding of where we're starting from and how we can validate the overall DENiM solution. And this is being brought together in a very clear validation plan and integration readiness of the tools for deployment at each of the sites. So overall, it's a 4-year program, and we're a year in. And DENiM, I suppose, ultimately what we aim to do is accelerate the energy transformation in manufacturing systems. And we want to achieve this by making the right information and the right technology, I suppose, available at the right time, in the right form, and accessible to the right people, empowering smart, energy efficient decision making within factories and across entire value chains. So as I said, the project will demonstrate the approaches involving 4 complex industrial case studies, the different sectors, showing replicability of the solution and promoting best practices for energy efficiency. Finally, I suppose DENiM will put the human and the individual worker at its heart, at its core, ensuring the sector is ready to embrace and participate in the energy transition, both within their working environment, but also beyond in their everyday lives. If you want to find out any more, thanks very much for your attention. The project is ramping up fully now in terms of developing the technologies and rolling them out. So if you want to follow the progress and the outcomes, you can get us out a number of different channels, the website, Twitter, LinkedIn, or get in touch directly through email if you want any more information. So that's it from DENiM perspective. Thanks for your attention, and I think we can take questions after all the speakers. So I think, Francisco, I think you're next on the presenters list.
Okay. So, okay, do you see my screen?
Yes.
Perfect, thank you. So, good evening, everybody. My name is Francisco Morentin. I'm the Ecofat project coordinator, and I'm going to present you the Ecofat project that, as DENiM previously presented, belongs to the same call. So, as you will see, we have some common issues in targets and in internal developers. So, starting with the formal definition of ECOFACT. ECOFACT stands for Eco-Innovative Energy Factory Management System based on enhanced LCA and LCCA towards resource efficient manufacturing. It's not a very friendly name, honestly speaking. We will try to explain our ECOFAT concept in a more simplified way during this presentation. As formal time framework, this project started in October last year, and we are also a 4-year project. So our formal abstract says that we want to optimize the energy performance of the production systems in line with the possible relevant production constraints, while at the same time we introduce a marketing approach through the concept of energy and environmental signature. Okay, so life cycle or perspective life cycle analysis again. Okay. Regarding Our ECOFAT consortium, we are officially 20 partners. Indeed, we are 21 because we have 2 Fraunhofer institutes, but they only account as 1 partner. And we are located, our partners are located in 7 different countries: Germany, Spain, Italy, Netherlands, Greece, Ireland, and Turkey. We have, in our consortium, we have 7 research centers, 4 big industrials that will perform as 4 big industrial demos, and 20 small and medium enterprises. Okay. So what's the ECOFAT main objective? Our main objective is to develop and demonstrate up to tier L7 an eco-innovative energy factory management platform based on improved dynamic life cycle analysis and life cycle cost calculations or methodology, okay? And the key word here is platform, okay? And this platform is based by the effective combination of different ICTs or related with collecting and processing data. So one of the biggest challenges is how can we collect data in a complex industrial manufacturing scenario. So as I mentioned, we aim to develop a platform, and this platform is formed by what is usually called as level and components. Levels are the typical levels of this kind of platforms. We will talk a little bit. And components are indeed the, let's say, the different services that has to be developed within the ECOFAT project. So we have 4 levels, and we will have on top of that the components. Regarding the levels of a platform, on the lower level, we will have the field level, which is basically the connected product and machineries. Basically, this is the industrial facilities equipment. On top of that field level, we will have the edge control layer, okay, for real-time data acquisition and visibility. And on top, on these 2 lower levels, we will have the data brokerage layer that provides bridging sites information between the lower levels and the cloud data services on top of that. And obviously the applications and service layer, which is basically where the different services and components will be implemented, okay? The ECOFAT platform is mostly deployed on the 2 higher levels. And regarding the components, we have considered 10 possible components divided in 5 branches or 5 different clusters of components. And we will go one by one in the next slides, but basically we have interoperability components, operations management components, energy aware manufacturing components, environmental aware manufacturing components, and what we have called overarching or global components. So starting with the first component, the interoperability component, it's basically also split in 2 internal components. First, we want to develop hardware boxes solutions to integrate different sensors to be deployed on, a specific factory machinery that required a specific, hardware box, and also the industrial Internet of Things connection drivers to connect these hardware boxes to the edge data acquisition system. And also we consider a component, a software component, the data acquisition layer for interoperability with the edge. Okay, so a robust edge layer to homogenize real-time data from the industrial Internet of Things network system. Regarding operations management, we have consider two components. The first one is industrial digital twin. It will be an evolving digital twin of the manufacturing processes, and it will integrate different real-time data, models, energy, material flow simulations, and other issues of the factory facilities and the factory operations. And the other operations management component is the production planning algorithms, and it's basically algorithms for production scheduling strategies, considering real and forecast data in order to optimize the possible organization of the product based on resource availability, environmental constraints, or different optimal selections available. Regarding the energy-aware manufacturing components, in this case, we have considered two possible components: is industrial energy disaggregation, and it's algorithms, data analyze algorithms to unpack the total energy consumption collected by a single meter into individual contributions over a period of time. And the second energy-aware manufacturing component is in industrial energy flexibility. So it could be a set of algorithms to guarantee a stable and reliable energy supply to local manufacturing processes and usage optimization of own generation assets. So this industrial energy flexibility only makes sense when we are talking about factories that are equipped or have already installed their own generation assets, their own both electrical or thermical self-generation systems. And regarding the environmental aware manufacturing, we have the dynamic LCA and LCCA tool, which will provide near real-time data automated calculations for the sustainability of the manufacturing operations, and it will be based on parameterized LCA and LCCC models of the factories, of the demos in this case. And we also have considered what we call the supply chain collaboration tool. So a software service for sharing information among the different actors of the supply chain. So the suppliers of the factories will provide this LCA or LCC analysis of their own products, the products that the suppliers are sending to the factory, that basically are the raw materials of the demos of the project, and this already produced environmental impact will be incorporated into the LCA calculations that the factory is producing itself. And finally, the final cluster of components, the overarching components or the global components, we have considered the holistic decision support system, which will be a user interface and a set of dashboards where the system will provide recommendations based on multi-site criteria, based on the results provided by the previous components related with energy aware, environmental aware, and operations planning. And of course, as the system, as we're talking about factories and digital systems, cybersecurity mechanisms are mandatory, and the system must be designed in order to ensure safe, reliable, and non-risky operation of the system. Just to recap, we have the overall architecture of the platform, and we have the 4 levels we previously explained. On the bottom level, the field level, it's basically our demo facilities will be, the factory facilities will be connected and providing local data. On top of that, we have the edge layer. On top of that, we have the data brokerage layer, and obviously we have to deal with common data models for the information to be shared among the different levels and among the different components. And finally, we have the higher level, which is the apps and services layer. And on that higher level, the different components I just explained is where are located and operating, connecting through the data brokerage layer to provide and request the right information. Regarding the demonstration activities, Ecofat is a demonstration to market project, so we aim to test the Ecofat platform on real production facilities, and we have considered two demonstration levels. Let's say we have two pre-demos, so two facilities that are not real production installations. We have a cross-sectoral in Italy dedicated to additive manufacturing, and we have IW, the research factory in Germany, where they can produce car body components, but obviously it's a demonstration facility, it's not a real production facility. And finally, we have 4 demos, 1 white goods demo, 1 beverage demo, 1 food demo, and 1 automotive sector demo. And we are going to see each of them right now. So regarding the white goods demo, our white goods demo, it's the Arcelic Arctic washing machine factory located in Romania. It's a absolutely new, completely new factory. The construction was completed in 2018, and it's built according to the Industry 4.0 concept. So let's say the factory is already equipped with a lot of data recording systems of a lot of variables and parameters. Production started in 2019, and they are in ramp up phases, so increasing their production capacity. It's important to remark that this factory have got self-generation assets. They have a PV plant, and they also have a concentrator capable of producing electricity. Obviously, not all the required electricity for the factory. And they also have a concentrated solar panels capable of producing thermal energy. This thermal energy is used during the winter for heating purposes, and during the summer is connected to an absorption chiller for cooling purposes. Regarding the overview of these production processes, the manufacturing of washing machines can be, let's say, split in 3 main activities. The first one would be the mechanical production, where all the cabinet, all the drum, all the metallic structure of the washing machine is produced. Then we have all the plastic production, where all the plastic components of the washing machines are molded through injection presses. And finally, we have the assembly lines, which basically all the different components, both produced but also externally supplied components, are integrated along an assembly line. Okay, the main focus of the activities are mostly related with mechanical production, where is the most energy intensive stage. Okay. Okay, our second demo would be the Ecofat beverage demo. It's the Athenian Brewery, the beer factory of the company located in Thessaloniki, Greece. This Athenian Brewery company has got 2 breweries, and this one is the one that is involved in the project. The factory started its production in 1975, and the Athenian Brewery Company was bought or absorbed by the Heineken Group in 1982. It's the largest brewing company of Greece, and the factory here, the factory that belongs to that is involved in the demo, has got a production capacity of 850,000 hectoliters of beer per year. They produce beer in 3 formats: in cans, in bottles, and in kegs. Regarding the manufacturing processes of the beer brewery, they have all the different processes, starting with the malting, the brewing, fermentation, maturation, filtration, and finally packaging. And it's in this packaging state where the product manufacturing is differentiated according to the different type of products: bottles, cans, or containers, kegs. Okay, but and all the manufacturing processes except packaging are batches operation processes, while packaging operation is a continuous flow operation process. Okay, so it's different in terms of organization, in terms of measuring, in terms of a lot of things. Okay, main focus will be also on the packaging, but also without forgetting some of the batches steps where there are important electricity and natural gas consumptions. Our third demo, it's the food demo, is the Galletas Gullón or biscuit factory located in Spain. Okay, Galletas Gullón is the biggest biscuit manufacturer in Spain. This company has got 2 factories, both of them located in the same city, in Aguilar de Campo. Let's say oldest factory is the one that you can see at the back of the figure, is the brown one, and the newest factory is the one that appears on the front of the image, is the green and black building. Is this a new building? Is this new factory the one that is involved in the Ecofat project? It's a factory that it's not. It's more devoted to cereal-based products than to biscuits, although it also produces biscuits. So the classical dry biscuit is also manufactured there, and it's equipped with 11 production lines. In the manufacturing of biscuits, it's usually made in a specific production line. So if you have a production line to produce, for instance, lady fingers, you are not going to be able to produce dry biscuit in that line. So it's not possible, at least, to produce quite different biscuits in the same production line. Some lines are capable of producing 2 similar products, but these products must be similar. Okay, they cannot be completely different. And regarding the overview of the activities, the focus of the Ecofat demonstration in this factory will be somehow restricted to 2 of the 11 production lines. One production line is devoted to rice and corn cakes, so fully cereal-based products, while the second production line is dedicated to soft and baked cereals. So, but in any case, the selected lines are dual production lines in the sense that they can produce more than one different product. So that gives a special complexity. And as you can see here in this diagram, this is a general representation of all the possible steps that a biscuit or a cereal-based product can go through. Obviously, they don't go alone, all of them, depending on the product, follows one or follows others, okay? And regarding the energy consumption, it's an important key here. As you can see, electricity and natural gas consumption are quite similar, and that's not typical in the case of dry biscuits. Dry biscuits factory usually have 2 or 3 times natural gas consumption than electricity consumption. But as I mentioned, this is not strictly a biscuit factory. Let's say it's biscuit factory, but it's also cereal-based product factory. And finally, our fourth demo is the automotive demo. It's the Tofaş automobile factory located in Turkey, in Bursa. Obviously, taking into account all the manufacturing steps to produce a car will be absolutely too large demo, and the scope of the project is restricted to the car body paint shop. So this factory produces 4 different brands of automotives, 20% of the Turkish automotive industrial production, and they produce 2 clear different types of vehicles. They produce passenger cars, but they also produce light commercial vehicles. And all of them, of course, are painted in the car body paint shop. That is the demo of the Ecofat. And regarding the general steps, the paint shop of this factory is a classical paint shop process, starting with the E-coat lines, then sealing and PVC, primer line, top coat lines, and finishing, where there is plenty of energy consumption, and there are plenty of energy meters, although a lot of them are still missing and there will be needed to be installed. And just to finish, and just to make a clear idea of what we call the Ecofat concept, basically what we would like to do is to collect production process knowledge, professional simulation tools, energy and resource planning standards, and combine everything in order to develop, demonstrate, firstly, a methodology, and second, a platform for boosting the efficiency, but the efficiency for both, for energy, but also for material resources at factory level. And just one sentence I like to remind when I make project presentations is related with Lord Kelvin, and one famous sentence he said more than 100 years ago, and he basically said, what is not defined cannot be measured, what is not measured cannot be improved, what is not improved is always degraded. And more than 100 years ago, we find that what we want to develop is innovative ways to firstly define, second measure, and finally improve the energy efficiency and the environmental impact of complex modern manufacturing processes. Okay, that's indeed the main objective of the Ecofat project. So how to keep up with the latest, as all the projects, you can contact us through the website, social media, events, or newsletter. And that's all. Thanks for listening, and thank you very much.
Thanks, Francisco. Andrea? Hi, Andrea.
Let me just share the screen. I think you should be capable of seeing my screen on. Can you please confirm it, Alan?
Not yet. Can see. Yes, no, can see it perfect.
Okay. Can you see it?
Yes, perfect. Now I can see it.
Okay, thanks so much. As math is low, there was a problem with connection just a couple of minutes ago, striking ourselves. So again, good morning and good afternoon, everybody. My name is Andrea Ballerino from CNR. My background is on automation and control system. I'm gonna lead you through the journey as a project coordinator of the Commission project. For lifecycle optimization and energy efficiency strategies with making platform.
Sorry, Andrea, do you hear me? I have problem with the noise. If I'm the only one that is having it, it's not a problem. But if the rest is having, your voice is cracking constantly.
The same for me.
Okay. So maybe I suggest you turn off the camera. This way we can save a little bit of bandwidth and maybe we can improve the sound. I'm afraid that it sounds still...
The audio is the same, Andrea, I'm afraid.
Yeah. It's even worse, sorry.
Does it sound better? Or it's
not so much, sorry.
So it's still bad.
Yes, it keeps cutting in and out.
Sorry about that, honestly. It was up and running till the very beginning.
Do you have any other app running on the computers that may require bandwidth? You know, nothing.
Nothing. Okay. Nothing. That's. Let me do like this.
Is it? Can you hear me?
Yes.
Yes.
You can hear you now.
But is it still bad, or it sounds slightly better?
Well, at least it's not, you know, constantly cutting.
Okay.
There is a little bit of background noise, but there is not, you know, constant cuts in the sound.
Andrea, I can maybe share the slides here if you want to just keep your audio and we can see instead of you adding the bandwidth or sharing the slides as well.
Let me try to operate and see. Can you still see my screen? Share.
No.
Okay. Okay.
Yes.
Do you see it now? Okay. Let's hope that now things are supporting us. So, as I was saying before, we have heard about different perspectives on energy efficiency, and here we will try to recollect and present you the two Commission approach towards energy efficiency. Today, energy and life cycle management is something that is taking place basically ex post, so after production is being managed, and therefore there is normally an assessment of how things are well or badly going after the production is being performed. This means basically that there is no homogeneous or there is an incomplete information availability as for granularity, and there is practically the possibility to transform the information to respective actuation level. So the problem is to try and bring energy and life cycle management as something that's taking place concurrently with production, in order to be capable of moving from after the things are done to in between, so as to provide the possibility to complete and characterize the information flow, to synchronize it in time, so as to give the decision-making level the possibility to efficiently and sustainably steer the production, considering energy and sustainability dimensions. And this pertains manufacturing processes, but also products. So E2Commission is about anticipating and empowering decision-making. So it addresses the completion, the synchronization, and the energy efficiency and sustainability production steering process. So the model on top of which E2Commission wants to leverage of the factory considers the capability to be in the position of perceiving, monitoring both energy and material flows, but also to consider events that moves across this dimension and which cause the change in normal behavior patterns, because this deviation, this disruption are the elements that should be taken into account. One dimension taking this into account relates to the capability of being predictive, so the capability to detect, adapt, and optimize, and the productivity and eco-friendliness constraints. So being adaptable, being scalable is a consequence of these first two levels, to be capable of being responsive and replicable, and acting in an energy, but also sustainability perspective and a life cycle perspective is of utmost importance. So the purpose, the overall high-level objective of E2Commission is to address the optimization of energy at various levels, considering the whole life cycle. So monitoring, predicting, evaluating the impact of the behavior of the factory across energy and life cycle dimensions is important, because we have to adapt and optimize, let's say, in real time, but also across different scales in the factory, but also across the factory when we come to the supply and value chain dimensions. So what does this mean? What does anticipating mean? It means that we have materials, energy, water, some, let's say, colored flows across the point families, but there are also some elements which are not fully detected. So the picture is not homogeneous. So we have to color and characterize all the flow, and to transform this identified image into an harmonized image, which is capable of considering the whole energy consumption dimension across the production till the distribution. So to complete the flow, to make it a live flow, so to make it varying based on the real-time behavior of the factory, because we have fluctuation, we have variations, and so we have to cope and to optimize dynamically the things, to try and understand out of this dynamic image which is the part that we can make and we can optimize in order to make it more efficient. The same concept can be applied to the sustainability dimension, where environmental impact is undergoing basically the same situations. So we have to understand how to make it dynamic, how to make it also predictable, and understand where and how we can save and make things more sustainably happening. So if this are the two dimensions that spans in the factory and partially across the supply chain, the issue is that we cannot consider the two dimensions separately, but they are kind of a unique coupled dual problem, because we cannot think of acting on one dimension without acting on the other one. So E2 Commission wants to challenge this problem through the achievement of dedicated objectives to try and give tools to optimize this complex energy and sustainability problem across factory and supply chain. In order to do so, we are basically leveraging within the project 4 different elements, which I will now try to high level describe in order to give you a short journey across the outcomes and the tools that we are developing within the project. So as we have also heard from before, the basic problem is that we have factories with several different degrees of digitalization, degrees of automation, degrees of awareness of energy and sustainability dimensions. So we want to act into E2 Commission in order to move from the question mark to the exclamation mark, meaning to try and raise, complete, and describe a digital picture which is energy and sustainability conscious, to try and raise the awareness on the dimension. This is the first level. The second level is to look across the streams of data and across the data mirrored against also historical data in order to discover critical events or disrupting events or patterns, those that are making not only the bias but above all the difference, in order to empower the fourth level, which is the one where decision making takes place on a number of different levels, from simulation to life cycle assessment to energy planning till life cycle driven supply chain. So if this is the picture, this have to be provided not as a set of standalone tools, but as a framework, so as tools embedded into a decision support platform capable of synergically optimizing energy and life cycle management. So if we start from the shop floor, the purpose is that we have to complete and characterize and synchronize our digital image with respect to the existing shop floor situation. This recalls about modularity and scalability in the automation and capability to build upon life cycle related digital twinning of factory assets. So in a nutshell, here the first objective that we are developing is to try to act with our innovations at a point in which there is a possibility to integrate and complement existing automation, steering it towards edge control dimensions, so opening new event-based control system management. And this recalls about how to complement and also partially revamp and augment the level of automation systems, because it is where we retrieve information and it's where we have to get back to act, to propagate the control action. The second element is related to building digital twin of specific asset at shop floor. And here the problem is how to augment the digital twin dimension with the informations capable of achieving energy conscious digital model. Here there is the problem of how to reduce, which kind of model to use, how to reduce the reduction strategy of the models in order to capture the problems and the dynamics and make them available in order to act on top of them. Once that we have achieved the first level, now we come to the decision making. And in order to empower decision making, we have basically 3 levels. The first one pertains with looking at the streams of data which are lively, let me say, coming from the shop floor towards the digital world in order to analyze them and to empower a comprehensive simulation environment with energy environmental performance. If we look at the very first result, this reveals as two different sides of a coin. The first problem is, how can I sit on top of data stream, being capable of handling them in order to extract reliable information to update the models. So we have to detect which are the meaningful portion of the model which have to be updated and how to update it. The second element is to provide analytics to extract at higher knowledge layer elements out of the behavior of office to find the root cause, performance indicator, and try to provide element to dig into that to let complex situation emerge. Once that we have come to this level, we have the elements to try and give the first decision-making tool towards the user, which is the capability to evolve what is scenario simulation and virtual performance assessment of the plant, having both energy and life cycle models embedded and being continuously updated with the runtime data that are pre-processed and updated via this collection analytics and IoT mechanism that I was mentioning before. So to have in the end a tool to consider production, energy and sustainability performance together. So to have a unique, let me say, holistic view of how things are going and how things would be going if certain decisions are to be taken. The second element of decision making is related to the optimization. And here we move to planning and scheduling level, being it energy conscious. We move to a dimension where we have to optimize and commit smart thermal grids. We are at the level where we are considering life cycle assessment and costing tools, not of what has been done, but of what is being done and what will be done in the coming future. This basically gives, these three tools basically touch three different elements of optimization. The first is, how can I, based on a dynamically changing and energy sensitive model of the shop floor, how can I plan production in order to take advantage of the flexibility in energy contract coming from energy price variable on the market, but leveraging the degrees of freedom. It means, how can I rearrange different operating modes in different operating stations so as to achieve an overall consumption pattern which can adapt on the power, energy consumption and costs on market, on energy buying price on the market. The second aspect is, how can I commit the smart thermal grid elements? So how can I commit the cogeneration systems? How can I commit all the, let's say, and let me call them ancillary systems in order to coordinate and balance the load together with the balancing which is coming out from the factory, which means committing them in order to be varying on a dynamic base, coupling them together with the dynamic demand which is coming out from the factory, out of the energy wire planning and scheduling. So that's a complete complex problem. The third element I was mentioning deals with a tool which is capable to not only consider and assess life cycle assessment and costing at factory level against emerging certification streams, but also consider and predict the environmental footprint based on advanced learning technique. Because here the point is, I want to evaluate elements for future environmental performance to understand where and how can I improve sustainability in due time to take decision for to put in practice the elements to get this better sustainable performance. The fourth element is basically acting at supply chain level. Here the problem is basically related to how can I sustainable think of production before putting it in place. So how can I think of new product based on all the possibilities that I've triggered with the previous tools in order to put new products in production in a conscious way. And the further aspect is related to supply chain management. So here the point is incorporate energy and life cycle conscious models for a new way of managing supply chain. So in order to create and embed sustainable mechanism in the supply chain management. And this pretty much recalls about also cooperation mechanism across companies. We will touch this point later on when we talk about the pilot. If these are the innovations, if these are the tools that will be placed and will be developed and will be nested into the platform, we are gonna test and validate our E2 Commission platform in 4 different pilots across 2 separate value chains. We have the woodworking value chain and the food and beverage value chain. The first one sees our Turkish partner Kastamonu, which is on the MDF production, so medium density fiberboard panel production. And downstream we have Royo, which is a Spanish manufacturer, which is a furniture manufacturer particularly. When we move to the food and beverage, I'm sharing the brewery scenario. So we are covering the scenarios related with Mahu, which is San Miguel, which is a Spanish brewery, working on a bottling line, and we have the distribution and retail with the Spanish partner named Condis. Just opening a bit on this to let you understand the difficulties and the possibilities that we have to face. Kastamonu is the 7th world manufacturer of panel board productions. The factory that we are considering for the project is the Gebze plant in Turkey. And it has a 500,000 panel production per year. It's a very automatized factory. And here the problem that we are facing is how to increase energy efficiency in a continuous process, because here the process moves from the wood chipping to the mat production, and how to serve this optimization with cogeneration systems, concurrent optimization. So there is a problem related to the process optimization, there is a problem related to the cogeneration systems. We have to look and dig into digital twinning and simulation activities and to optimization of the process. We have to consider analytics to get out meaningful cross-correlation across this multi-step production, and to serve the thermal aspect, which is very much important in this scenario. So to serve steam and hot gas out of gas turbines in order to have the combined effect in between the two sides of the coin, so the process and the cogeneration together. When we move to Royo is a furniture manufacturer placed in Quart Spain. Here we have the typical manufacturing layout. So we have all the manufacturing change from sizing to edge bonding to machining. We have chemical and treatment related to the lacquering part, and we have the assembly. Here we're gonna manage the complexity of a very fragmented energy image, and we will work on energy-aware scheduling, so better production scheduling and managing, assessing it virtually with energy and life cycle-oriented line simulation, and managing the two sides of the ancillary system, coupling and optimization, which are related to compressor management as a serving the line and suction system as aspiration, in a very fragmented scenario, as I was mentioning before. So we move from continuous to discrete in the case of woodworking. When we go to the food and beverage, here we have the Mahou brewery in Alavera, Spain. We're going to focus on the high-speed filling and packing line. So after the brewery process, and here the challenge is, since this is a very high-speed process where energy comes from thermal energy, from steam, but on a very high-speed process, here the challenge is how to optimize things that are very frequently and changing at a high frequency rate, and we have to try and find improvement points in high throughput production equipment such as the filler and so on. The fourth, which is a more supply chain centered use case, deals with Condis. Condis is a distribution and retail management group based in Spain. We're gonna work on the Moncada distribution center, which is a quite meaningful center serving either Condis supermarkets, so internal supermarket, and external third-party retail point. And here we have a quite complex and diversified reality with this up to 70 million cases per year handled. Here the problem is to embed the sustainability across distribution and logistics, so to look at particularly the fresh food part, where we can take energy, but above also sustainability related choices in cooperation with also partners which are cooperating with Condis in the supply chain. So it is a factory, or better to say a distribution center related problem, but also a supply chain related. And in this sense, Mahou is an actor that will be cooperating with Condis in the opening the mutual supply chain related optimization problem. We are similar to the other project. The project is in its 11th month. We have the full definition of the working in the food and beverage sectors. We'll be drafting the whole automation platform, and the module that you see now are part of the other software that will be completed, and we're starting the requirement and deployment analysis of the single tools. It is a very intense activity. Here you see the rich and diversified consortium, which is part of this adventure. And as a last point, here you can find, let me say, all the points through which you can get in contact with us, so in terms of website, Twitter, and all the social media. And I would say that's it on my side. I'm sorry for the initial problem. I hope that you have enjoyed the journey through the commission. Thanks to all of you.
Thanks, Andrea. That's perfect. So that covers the project's presentations. So we planned the agenda to take a quick kind of comfort break there, maybe for 10 minutes before we move on to the next session. Before that, maybe if there's any particular questions for the speakers or on any of the projects, You can put it into the Q&A session there on the chat. And if there's no questions in there at the moment, then perhaps they'll come up as we discuss in the subsequent sections anyway. So what we might do is we might take a 10-minute break. So it's now 1:15. So maybe if we come back at maybe just after 5 or 4, depending on where you are, and we can continue on with the next part of the session. So grab a coffee and come back, and hopefully then we'll have more interaction. Please as well try to log into the Miro board with the link. I'll just resend it again so it's at the bottom of the chat, and we'll use that then in the subsequent sections. So we'll see you all back here in 10 minutes time.
Perfect. See you.
Okay, perfect. See you in 10 minutes.
Okay, see you. Alan, are you there?
Okay, everybody, I think we're back online. And I see there's a few more people connected to Miro, which is great. Okay, I hope you got an insight into the activities of the different projects. It was the first time I heard ECOFACT and eco-automation in such detail, so it was great to see. And unsurprisingly, I suppose, since all the projects are targeting the same impacts, that there's the synergies between them. So we had planned to go through of capturing those synergies through the Miro board, but I think in the interest of time, I think it's probably more interesting, considering those who are online, to look at the pathways and dive into that activity, and we can populate this synergies between projects offline. So the Miro board will be open and accessible to the different projects, and we can add that information as we go along. And I think the presentations were quite good in terms of capturing the specific elements of it, so it'll be easy to map those synergies between them and identifying which opportunities we can leverage for further collaboration. So I'll share the screen from the Miro perspective here. I hope everyone can see it okay. And what we can do is we can talk through it, and hopefully you might give your input through the Miro or through the chat function. And if someone would like to speak, you can request sharing of the audio. Just put into the chat that you'd like to speak, and I can add you. There's a limited number, so I can add and remove as we go along. But if someone would like to speak up and talk about anything, then we can do that. So in terms of what we're trying to achieve with this pathway, we need to first identify or define maybe what we mean by pathway. So the pathway for us is made up of different levels or milestones, and they represent the evolving steps towards the most advanced situation. So for us, it's about defining the pathway for energy efficiency, with a particular emphasis on achieving that through the use of digital technologies. So how we can use the pathways after is that it can facilitate and stimulate the discussion and identification of innovation strategies. So this is for the companies or the sector-specific pilots that we have in the projects, and allow us then to demonstrate how the research that we're doing and the innovation in the projects are contributing to the future deployment of energy-efficient manufacturing. Okay, so we're taking inspiration here from the Connected Factories project that have defined basically a number of pathways and kind of cross-cutting aspects to enable digitization and connected factories. So here's an example of the outcome of these pathways, and you'll see if you're familiar with EFRA that these pathways have transposed into the EFRA innovation platform, and then it maps projects across these different pathways, which is very interesting. And we can leverage the same approach, I think, within our project to firstly define what we feel these pathways for energy efficiency are, okay, and what are the enabling key enablers and cross-cutting factors that the projects are addressing, and then kind of map that to the specific use case scenarios, or identify basically where the gaps are maybe for future collaboration as well. So each of these levels have a different milestones, and that's what we want to try to capture. So the first kind of phase of that really is around kind of assessing where we are, what's the current situation, what's the readiness assessment for energy efficient manufacturing. So if you see on the screen here, we've 3 different levels of readiness. So motivation readiness, technology readiness, and organizational readiness. So Mark Power from the ECOFAT project will facilitate maybe the discussion around each of these readiness activities, and what we want to do is, or what we would encourage you to do is, through the Miro board, add your post-its, add your thoughts, whatever you feel fits under each of those boxes. And Mark will maybe talk about the guiding questions to support and facilitate that.
That's fine, Alan. Thanks for that. Yeah, so I'll just take you through the questions. We may as well start from the top with motivational readiness and look at what is driving the need to change. So I suppose for yourselves, for your project, who are the stakeholders with regards to energy efficient manufacturing and why?
Okay, so what you can do is pick a post-it, drag it across. And provide your thoughts.
Yeah, so just looking at some of the ones that are popping up there, finance departments, regulation, ESG compliance. Just waiting for a few more to come on screen.
So basically what we're interested in understanding is what's driving the need for change, what's going to push manufacturers to take that leap to engage with energy efficiency in their processes. So one of the challenges highlighted across all of the projects was energy efficiency is kind of sometimes an afterthought, and the focus is really on the process and the manufacturing process. So who do we need to engage with to kind of make that mindset change and shift? So certainly from a regulation perspective, the companies will be driven to make changes and address energy efficiency. And from a financial perspective, I guess there has to be the resources made available to achieve that. Solution providers is also coming in there. So obviously we need the tools and the services and the systems to allow them to maximize the opportunities. Another interesting one is corporate social responsibility.
Yeah.
So maybe aspects like the energy labeling could kind of support that, to get visibility to the customers for the products that are being developed, you know. So that's great. We continue to populate that as we're going along.
Yeah.
I suppose the other questions then are.
Yeah, so what role do the stakeholders have in influencing change? So yeah, so some of the ones coming in there, it's just obviously giving enablers a better understanding of the energy, looking at, I suppose, the bigger view of what's happening, what's the problem that we're trying to, I suppose, fix it and improve. So that seems to be the ones coming in there. Yeah, there's a lot coming in around information seems to be a key one. Data sharing. Yeah.
Okay, maybe some good things captured there.
Yeah, a lot around information sharing and data sharing, and I think providing an understanding it seems to be a key one that's been mentioned there a few times. So.
Yeah, it's interesting as well, the customer as a stakeholder, and their influence on it. I mean, I would say from a project perspective, we're less focused on the end customer and more on inside the factory. Or maybe eco-automation that's looking at the supply chain more broadly. Taxes is an interesting one. Okay, if we want to move on there, just in the interest of time, to maybe the technology readiness.
Yeah. I think that section is getting a bit full, so we'll head down to the next one. So yeah, just looking at the technology readiness and the existing technologies, I suppose, what are the levels of integration across systems along the product lifecycle?
Yeah, I think it was kind of highlighted in the slides and the presentations, that it's the level of integration and collaboration across these systems is quite limited as it is, and that's one of the challenges I suppose we're all trying to address. I think the kind of common data models and this kind of stuff can maybe support that, but yeah, in terms of the barriers, then Mark, you can see cybersecurity, obviously,
Yes,
data privacy, standardization needed.
Yeah, kind of lack of knowledge there, lack of confidence, I suppose, about security, but yeah, all very good. Then suppose we can head down to the next one now, the organizational readiness. Just look at what skills and resources are required to support EE. So yeah, the LCA, the LCCA are mentioned there, looking at interpreting results, trade-offs. So looking at digitechnology also.
Maybe the question could be what specific skills do we see are lacking in the sectors, you know? Just with the other speakers, I mean, our other panelists, if you're having problems, I know Susan's having some issues unmuting. I just wonder if anyone else is having a problem. Susan, you might check up at the top in the browser if there's anything blocking the camera or microphone. Maybe you can reshare. I suppose a big question, and maybe it's not easy to answer. Do organizations understand the challenges facing them to achieve energy efficiency? So there's a lot of maybe support needed to help organizations address that. Maybe not just from a technology perspective, but also kind of understanding where to even begin, understanding where energy flows are, where the low-hanging fruit could be.
I am just checking my audio. Can I be heard?
Yeah, yeah.
Fabulous. No, you've missed out all the absolute gold I've been talking about now a lot. It's been unfortunate for you. I had to reconnect, so I don't know if anyone else is experiencing difficulties in terms of accessing any functionality. But just in terms of technology readiness, I don't know if there's any comments or feedback in relation to either standards-based technology or proprietary solution customizations, etc. I think that's interesting when we're talking about technology and technology adoption.
Yeah, just some great things being put in there, which is fantastic. This is an interesting one. I don't know. Usually, energy efficiency goes against maintainability in the factories. I don't know if the individual might maybe want to expand on that a little bit, maybe. Maybe it refers to kind of maintaining the throughput and the production levels. And sometimes energy efficiency can counteract that.
Yes, Alan, I wrote that indeed. In my experience, sometimes when you implement efficiency measures on the factories, you have to modify the production systems in order to make it at least a little bit more complex sometimes. And you know, maintenance people really love simple things. Really, maintenance people usually hate complex things. You know, the more complex, the more things that can failure, the worse life they are going to have. So, so
even when they're brewing beer.
Yeah, that's an interesting point, Francisco. And I suppose we have to look at the cost of these energy efficiency solutions and its cost in terms of skills, capital cost, etc. Does that offset the actual ultimate savings? So again, you know, as part of our return on investment, maybe you have to broaden it out to the human cost as well as the energy cost itself.
Yeah, exactly.
Just maybe, Andrea and Francisco, in terms of the strategy and the pilot sectors that we have, did they already have kind of specific targets around energy efficiency and kind of timeframes to reduce their energy consumption? Or is it very much, okay, let's look at the processes within this project now and see what we can do?
No, obviously they have their own targets of reducing, you know, every year their specific energy consumption. Obviously measuring, you know, energy consumption per functional unit, energy consumption per hectoliter of beer or per 100 kilograms of biscuit or per washing machine. But it's exactly the same philosophy as they have in reducing their overall cost. So, you know, next year you have to reduce your overall cost in 2%. So that's the point, but there is not a specific, you know, criteria for energy efficiency.
Yeah.
On the other hand, and I guess it's something we will find when we go ahead with the demonstration activities. Sometimes energy efficiency depends quite a lot on, let's say, production efficiency. Let's say, you know, how good or bad you are producing one thing in terms of basically how many breakdowns of the system, unexpected stops, things like that you have. So usually the more you are able to produce in 1 hour, usually the more efficient you are in terms of energy efficiency also. I mean, because usually if you don't produce your nominal production in one working shift or in a fixed period of time, because you have some kind of incident of breakdown or something like that, probably you will also have bad figures in terms of energy efficiency for that period of time.
So the use of fault detection and diagnosis as well,
yeah,
kind of to support that in a proactive manner is important.
Yeah. So sometimes it's difficult to measure, let's say, to measure the energy efficiency because energy efficiency is fully covered by production efficiency. So your stop times due to any kind of breakdown affects your consumption much more than the proper settings of your production for the energy efficiency.
So it's important to be able to accurately represent where the energy savings have occurred. And the context, yeah. Good. Yeah, I think we've collected quite a lot in this terms of the current situation, and we can use that to inform maybe the pathways. So if we move to the next slide, it's actually defining the pathway itself. So you can see here, if you follow me on the screen, we've created this kind of matrix, if you like, and we didn't want to get too complicated with it. This is just the first draft, and we can see maybe how we go beyond this, and maybe there's other types of pathways that we can set for across the activities we're doing in the projects. But as I said earlier, the pathway to energy efficiency, we want to kind of create this holistic view that industry can leverage, then with a kind of an emphasis on digital technologies to allow them to enable more energy efficient manufacturing. So we've initially defined the kind of high level levels or milestones, as they're called in the project. So the first one being that there's quite limited visibility of energy performance. So this really is about awareness and understanding where the energy leakages are happening. The second level then is having kind of monitoring at the process level of energy performance and energy usage. So this is kind of the sensing level. And then if we move to the energy performance insight layer, that's a little bit more detailed in terms of using that data that we can extract from the process level to inform maybe more of an understanding of how energy is being used across a process or plant or whatever. And then the fourth level is energy efficient informed decision making. So we can get that insight, get that data, and help us make better decisions, whether it be scheduling or planning, parameter optimization, whatever that might be. And then I suppose the highest level is looking at having kind of an online and near real-time continuous energy management. And that's the kind of holy grail or the kind of ambition, I suppose, of all our projects to push the industry partners towards that, where we can optimize parameters online to make sure that we continuously save energy and maintain our targets, and also to have that kind of, again, collaborative and holistic view of energy management across all the different aspects of the value chain. So the other perspective of this is that you don't necessarily expect a company to fall into one level only. They can actually sit across different levels depending on where they are, what they're doing, and what they're trying to achieve. But what we can use this kind of mapping for is to say, okay, where do we take the outputs of DENiM, ECOFACT, and E2Commission to enable an industry partner to move along these pathways? What are the tools that are help them kind of move from a manual data acquisition to maybe more automated extraction of information? So what we want to do maybe in the first instance is to define these milestones under the levels. Okay, so we've done the first one here. So if we say the kind of most basic view of some of the factories are it's manual data acquisition from an energy performance perspective. You know, they're using Excel to maybe every year to run a report on energy performance or usage. It's not really integrated in their kind of assessment of performance or products or whatever. And there's very limited metering on the process level. Maybe they have it at the facility level at the factory, at the main incomer maybe, but they don't really have any details of that. And I see someone added a post-it saying that there's no maybe impact assessment in place. So the idea I know is if we move to the next level, what would that look like for the factories? So drag your post-its, pop something in there, and we can maybe tidy it up and kind of consolidate on a view after a few minutes. So look across the different levels and see what you feel would be appropriate at that. And if there's any questions.
Alan, sorry, here the color has not a meaning, right?
No, the color has no meaning.
Okay.
It's just the color that was there.
Yeah.
So I suppose what's meaningful is the different levels. It's just, as we move along the pathway, we're always improving,
Yeah, I think that in this exercise is at least important to start trying to put things that are evolving. Then probably, of course, it's not now the moment to identify if it's correctly on the second place or in the third place, but
yes.
we understand that it's progressing.
Exactly, yeah. If we can put down the kind of things that would progress, and then we can maybe put it in the right column or level afterwards. Great to see the cursor zooming around and inputs going in anyway. So I think we're getting there with a few suggestions or proposals, but what we can also look at as well, besides the individual levels, is what are the key enablers and the cross-cutting factors. And maybe we can link that back to what you've heard maybe in the presentations and the slides of what the projects are doing that could maybe help. And it's not a direct mapping to the rows, just if we can just list them in that column, and then we can do the alignment afterwards.
So maybe a question for the representatives of the projects we have here today. Milestones 1 to 5, represent kind of where we are and where we want to go in terms of the pilots and your experiences of the pilots today. Would you say that the majority of the pilots kind of sit around milestone 1 and 2, or is it more milestone 1?
I think from the DENiM perspective, at least it varies across each of the pilots. So we would say the Met pilot is around 1 or 2 even. But the other pilots would be much further down the line. I don't know about eco-automation and ECOFACT.
In my case, I would say it's quite different from one demo to another. I mean, and not necessarily the situation is, let's say, better in the newer demos than in the older demos. It depends quite a lot of how you've got the distribution of your energy consumption points. I mean, if you have a very clear view of where are your main energy consumers, you have 3 or 4 very clear machineries that are responsible of the 80% or 90% of the factory energy consumption. It's much more simple than if you have, let's say, 50 points or 60 points of energy consumption. That's a huge problem, and that's really the point. For instance, in the case of the biscuit factory, where you have 11 production lines, you have 11 ovens, you have 11 mixers, you have 11 packaging machines. So that's a problem in terms of you have to measure everything, multiply it by 11 times. So it creates not only a specific budget for monitoring hardware, but also, and it's an important question, a specific working role for who is going to read and evaluate all these energy consumption figures. And that's I think that's the importance of such a tool, in sense that if you had, let's say, 100 energy meters along your factory, and you have to review the values of these energy meters by your own, at the end nobody's going to make it. Okay, so
yeah, that's true. If I may add on this, the thing is quite, say, when you have few big consumers, it is because you are, let me say, on a process where there are 3 to 4 key points where the things are happening, and so it's simple to isolate the problem and to try to figure it out how to improve it. A typical example of the upside situation is the manufacturing sector in general. I'm referring to woodworking, but it's a clear example of manufacturing. Here, manufacturing, the cake is split, is very fragmented, as I was saying. So in the end, either we have companies that have a picture which is at factory level, or it's department level in the luckiest cases, or if you wanted to drill it down at the level of machine, you have to make the complexity explode. Otherwise, you can't save, because there is not a big consumers, but there are plenty of small consumers. So the cake is being done with many different fragmented contributions. But I'm afraid that the percentage of this situation is the majority in SMEs and manufacturing in general.
Yeah, and that's a good point, Andrea. And I suppose it raises another question. You know, who are the customers for the solutions being proposed by the projects here? How scalable and replicable are the solutions if we're talking about SMEs in the value chain right out the other side, where we're talking about, you know, large multinationals who themselves are massive energy users, etc. So are we trying to develop, you know, solutions one fits all, or are we going to end up, you know, tailoring for a particular customer with or a customer segment within the manufacturing sector itself? So I suppose the testing and understanding of the scalability and replicability of these solutions and looking at the solutions across the various pilot sectors should help with this. And I think it's a great opportunity, I suppose, that the projects have come together with such diverse pilot cases, you know, that we can potentially stress test the solutions from one project to another. You know, maybe it's more of a desk-based exercise, but it should certainly help us maybe identify who that customer is, what that business model is, and, you know, where we fit across the manufacturing sector itself.
Yeah, it's a general. I mean, the magic, the Aladdin's lamp is not out there, or at least I don't think that we're gonna find it soon. The thing is to have I would say to have a modular portfolio of things that can be plugged together, not necessarily in a fixed way, to combine them based on the needs of the specific case. But this comes after the very first barrier, which is the cost in instrumenting, because as Francisco was saying, in the end, either you have energy company from outside providing metering systems which are interesting, but up to a certain point, in terms of granularity of data, in terms of things that you are effectively monitoring, or you have to open the painful pot and invest on top of that, because I see in many cases people having feeling about what's going on rather than having information about what's going on. Mm-hmm. And I think that this is something that should be solved in any situation, in any case, especially for SMEs, I mean.
Yes, and I think, again, coming back maybe to the SMEs who are often cash poor, and what you suggested, Andrea, around a kind of a pick and mix option around, you know, what best suits me, what best suits my particular value chain, etc., and being able to, I suppose, leverage the plethora of tools and services that will come from these particular projects, I think is good. So creating this kind of shared marketplace with those opportunities for SMEs, I think it's certainly beneficial.
Yeah, I would say that one of the LCA-related marketplace in terms of exposing information for sharing could be something as a first achievement on top of that, so that the SME can try and grab another value out of there. When we come to the tool, as I was writing in the mirror, the first objection which is raised is, can I have something which can be smoothly placed into, that can be smoothly nested, and that can make me improve in a seamless way, which sounds like, can I get something better at, let me say, no cost, where no cost means not necessarily investment cost, but it means cost in nesting the solution, cost in plugging the solution in the production process, or in general. So this is a very general concern, and it's, as you can imagine, even more typical out of the SMEs.
Just one of the interesting things coming out on the pathways board here is what would be the highest level of achievement, because you can see someone has put, for example, the use of data analytics in the second level. So if we say the first level is that we have no visibility to jump then to data analytics straight away, is that there, or is digital twins really the ultimate one, or can digital twins be more effective earlier on in the pathway? Or even there's another one, visualization. So someone has data visualization kind of closer to the higher levels of the pathway, whereas I put it in, for example, in level 3, which is kind of a step up. Once you do the monitoring, the visualization is the kind of logical thing to do with it.
Now, is there a danger we become drowned? We're drowned in data, and we're trying to turn data into knowledge. And now with analytics, are we going to become drowned in analytics? What's the cutoff point? What granularity do we need to go at? And and that's where I suppose the skills. Do we have the personnel with the analytic skills to actually interpret the data, or are we going to present them with a whole load of data analytics and there's no one actually there to understand it? And I know while we're driving towards automation, we still very much will have the human in the loop. So how do we marry technology developments and skill developments and make sure they're all going hand in hand across this value chain?
Yeah, it's also about the maturity, though. So if you look at this, some people obviously think that manufacturing in some of the sectors are mature enough to be able to implement the data analytics quite early, whereas maybe different perspective.
Yeah, what's that maturity perspective from? Is it from the technology? Is it from the human capital? Is it from the organization itself?
Exactly.
Is it to invest in it? So that's why I'm saying it's much more of a broader question, and I suppose we have to look at all aspects of it, but ultimately we can't forget, I suppose, the human in this. So as I said, while we're pushing towards automation, digital twins, etc., we still need very much the human in the loop, and that's why the skills assessment, training, etc., is very important. And looking at the different modes of delivery, I suppose, around skills and upskilling, I think is a key component that we can't forget within these technology development projects.
Yeah, so I wasn't suggesting that we distinguish between them, but I suppose what I was maybe getting towards is it possible to have one pathway? You know what I mean? Maybe we have to have that pathway per sector.
Exactly, and I think we have to have we're going to have complementary pathways, but we need to look at the dependencies and the integration points of those pathways. It's much more complicated than a single pathway, for a single issue. And that's the interesting thing, is trying to marry those pathways and understand the integration points, the collaboration points, etc., and the dependencies. And that's what makes this exercise so interesting. We see how complicated it is for this particular pathway, but it's when we start looking at the bigger picture and how we actually, I suppose, resolve to integrate those pathways. And I suppose that's in effect what the projects are trying to do holistically anyway.
Yeah, and certainly you can see maybe from the presentations of the projects where we fit in,
Yes,
and where we map to kind of achieving these different levels along the pathway. Okay. I suppose so. Maybe just in terms of the other types of pathways. So this is very much focused around, the digital technologies and the perspective of that. But there's also maybe other pathways maybe linked towards the use of energy technology. So the use of renewables. You could have a pathway on its own about greening the production process, integrating renewable technologies and storage, etc. You probably could have a pathway around energy flexibility. And as you mentioned, Susan, the pathways around the upskilling to support energy efficiency and the use of these technologies. So I think maybe as a starting point to kind of marry back with the projects, the focus on the digital technologies makes a lot of sense. But I think it provides us with that kind of scope to explore further some other pathways or definitions for supporting industry and kind of achieving this energy efficiency. Okay, look, I think we're getting close to the end, and I do appreciate everybody's contribution to the Miro board. It'll remain active for some time as well if you want to revisit it and maybe take some insight on it. And in terms of next steps, for what we will do is we'll generate a kind of report from the project's perspective on today's workshop, capturing your inputs and your contributions at the different levels, so the pathways and the barriers, and we will build out those synergies between the projects also. So I don't know if there's any questions or any comments, or if anybody wants to discuss anything else in the last few minutes that we have.
Maybe just before we finish up, on behalf of the DENiM project, Eco-Automation and ECOFACT, we'd like to thank everyone for their participation. Your contributions have been great. The Miro board certainly makes for interesting reading and reflection. So we would be delighted to follow up with you in subsequent events. And I think Sustainable Places is an ideal home really to continue this collaboration, and the projects themselves, of course, will continue the collaboration offline. But just from myself, I found it to be a very interesting event. So thanks for your feedback and opinions to date. And thanks to my colleagues here today for the great presentations and support for this event.
Okay. With that, unless any project wants to share any upcoming events that they want to disseminate to the partners, I think we can leave it there.
Great. Thanks, everyone.
Yeah, thanks everyone.
Thanks everyone.
Thank you all. It was a pleasure. Bye-bye.
Cheers, everybody.
Bye.
Bye.